We are on Chapter 8, Lesson 5, and we are going to be using all of the formulas that we've talked about, some law of sines or law of cosines, trigonometry, to solve real-world problems, okay? First of all, let's do a little recap on vocab. An angle of elevation versus an angle of depression. An angle of elevation is going to be me, I'll put the definition actually, because I need the picture to do the definition. Okay, there we go. So an angle of elevation is when you're looking upward. So I'm standing here and I see that there is the top of a tree. And I want to know from my baseline of where I'm looking to the top of the tree, what's this angle of elevation? Or perhaps I'm standing on top of a lighthouse and I'm inside, obviously. I look down to say, oh, there's the shoreline, there's the beach, right? What's my angle of depression? Angle of depression is when I'm looking downward. So in example 1, I have to talk about angle 2 and angle 3, which is which. So in angle 2, I am going to be the person standing at the observation deck. And I'm at angle 2 looking towards the restaurant. So I'm looking at this restaurant. That's going to be an angle of elevation. So I'm back at the observation deck now, and I'm looking towards angle 3. This is someone on the street. I see this really cute guy down on the street. And I'm like, hey, hey, like yelling, you know. But he doesn't notice me because I'm way over here on the observation deck. But anyways, he's there. I'm looking downward. That's angle 3. Angle 3 is my angle of depression. Okay, looking up, looking down. Then it says how do angle 1 and angle 2 compare? Well, angle 1, you know, if I'm at the observation deck, angle 2 is obviously what I'm looking at for the restaurant. But this person on the restaurant could easily say my line of sight is straight ahead. If I'm, this angle 1 is going to be the same angle as angle 2, the same degrees. And what else? What else? Angle 2. Angle 2, well, they are the same size, right? You know, alternate interior angles. But angle 2 is my angle of elevation. I guess angle 1 could be an angle of depression, but the problem is that you would have to assume that this person standing at the restaurant can't look any higher than their head. That the top of their line of sight is the top of their head. Then you could say angle 1 is an angle of deep, like looking downward, but it's the whole point. How do angle 1 and angle 2 compare? They're equal. They have the same size. All right, downward. I'm going to go to example 2. We're going to start doing math. All right, this is one of those bungee jump attractions that are at, I don't know, doesn't like Knott's have one? Things like, places like that, I'm not sure. Okay, so this person, Reagan, stands halfway between 2 vertical posts. Look, it's 8 meters between them, okay? 2 bungee cords extend from the top of the posts. Let's just focus on one of the triangles. To Reagan's waist at a height of 1 meter. Okay, so she, because you know, it's around her waist, which means that from the waist to the top of the pole is how high the bungee is, but the pole itself goes all the way to the ground. So keep that in mind. She's 1 meter, or the bungee's at 1 meter at her waist. Okay. This 70 degrees is Reagan's what? Angle of what? What would you call the 70 degrees? Her angle of?
Elevation.
Elevation, because she's looking upwards. How tall are the vertical posts? Okay. Reagan's 1 meter just tells you how high like the bungee is. So really and truly, I'm gonna get this triangle right here. But then remember, there's 1 meter more. Let's worry about the one at the end. Okay. I've got 70 degrees. What other information do I know that I could fill out this triangle that I traced? Yeah.
The bottom.
The bottom is 4 because it's 8 from post to post. Okay, so that's 4. It's obviously a right triangle. I need to know how tall the post is. I want to know X. This is a right triangle. I'm good to use just normal sine or cosine or tangent. Which one shall I use? I have an angle. I have the side adjacent to it. I do not know the hypotenuse, but I know the side opposite to the angle. You've already helped. People on Zoom. Was that sine, cosine, or tangent?
Sine.
Sine is opposite over hypotenuse, but I don't know the hypotenuse. Can we think of something else to use?
Tangent.
Tangent, opposite over adjacent. Tangent, and you put the degrees right after, yeah? Tangent of 70-degree angle equals opposite over adjacent, x over 4. So, to solve this, solving for x, the 4 is on the denominator. I can, right? Multiply by 4 on both sides. You guys need calculators? Okay. Your calculations are going to be 4 times tangent of 70 degrees. What'd you get? What's the decimal answer? I know somebody's done. Four times 10, 70. What'd you guys get?
11.
11, which was it 10.98?
Yeah.
Which is 11. That means that this is 11 high. Now, remember where I stopped my triangle at her waist, because that's where the angle started, 70 degrees. So there's 1 more meter unaccounted for from her waist down to the floor of the ground. So the posts are 11 plus 1 meter for her height, right? The posts are 12 meters high. It's really important that you always know what your answer represents. $11, 11 people waiting in line, 11 meters, but it's 12, You add the 1 because she had this space from her waist down to the floor that we didn't count in our triangle. So I have to add 1 more meter. I'm going to move on to the next example. Okay, I got to get the picture. What's that?
Can you explain, like, why did you, like, add the 1? I didn't understand that part.
I added the 1 because look at where the angle is. Well, let me get to it. Look where the angle is. The angle starts, this 70-degree angle starts in her waistline, where the bungee like attaches to her body. See, this is the bungee going upward. Here's her waistline. But there's the floor, like the ground. And this post has more to go, 1 meter more, because it says that the bungee is 1 meter off the ground at her waist. So 1 meter is not accounted for in the posts. I only went from here to here on the post. I didn't go to the floor. Since the triangle started out high, I need to keep into account there's more to the post. There's 1 more meter because of her waist down to her feet. All right, the picture's in full view. All right, not mountain climbing, rock climbing. She's at an indoor rock climbing wall. Let me explain, everybody, because I don't know that many of you have done rock climbing. I had never gone rock climbing until I was in my 30s or so, I don't know. Unless someone in your family enjoys it, you might not go, you know? So, there's a man at the bottom. He's the, I don't know, support guy. What's he called? The instructor holds a safety rope. So he's the instructor. He's got a harness on. There's a rope attached to his little harness that he has on his body. He's holding the rope, keeping the rope tight so that the man up here doesn't just fall to the ground. If he lets go of the rope, the man up here doesn't have any tension to keep him up. The man on the ground also has lots of extra rope down by his feet because he can loosen it if this man needs to lower, because this guy's got to get down. The only way for this man up here to get down is for the instructor to just kind of loosen, and he hops down to the floor. So here's what's going on. If you'll see the image, and you can zoom in because you've got a color copy at home, the instructor starts here. I've got a triangle that it says is 75 degrees. Then I have the rope triangle, which goes up to the man. And that's, whole thing is 79. What's this little angle right here? If the whole angle is 79 and 75 of it is the inner triangle, what's this extra sliver of angle right here? How much? 4. They call it angle Y. 79 minus 75, 4 degrees. Okay. Then I know that this is 61 feet. I'll put it in blue because that was in blue. Okay. This is X degrees. It's a 90-degree angle. Let's look at the black triangle and the blue triangle. My black triangle has 79, 75, 90, and what's this up here though?
15.
90 plus 75 plus 15 degrees. So this is 15 degrees. Okay. Let's try and do what we can with what we're given. I filled in a missing angle in the black triangle. How big is angle X? Because 15 and X make a straight line. So 15 and X make a straight line. What's X? 15 and angle X make a straight line. What is it?
165.
And you've helped a lot, so take a break. 165. So angle X equals 180 minus 15, which is 165 degrees. Okay? So that's good. So here's what I've got. Blue triangle, which is totally like skinny and weird looking. $165, 4 degrees, 61 feet. I have 2 angles and a side. What does the question ask us? How much more rope should the instructor let out so that the student can make it to resting point R? Here's R. Here's T, where the student is now. The student is at T. See him? He's at T. He needs to drop down to R. This is what I need to find. He's going to go downward, and I need to find out how much. Okay, look what I've got. I've got a 165 angle and the opposite side. I've got a 4-degree angle and its opposite side. This is not a right triangle. I cannot use straightforward sine or cosine or tangent. I either need to use law of sines or law of cosines. If I have an angle and its opposite side, this angle and its opposite side, what law is that? Everyone in class has helped me, so I'm relying on Zoom now. Once again, the question is, an angle and its opposite side, an angle and its opposite side.
Law of sines.
Law of sines. Okay, an angle, 165, and its opposite side, 61. And another angle, this small teeny sliver of an angle, and its opposite side. We've practiced this, we can do this successfully. Cross multiply. X times the sine of 165 equals 61 times the sine of 4 degrees small. Here's our calculators. All right, I'm solving for X. Let me get another color. This sine of 165 needs to move over. Right? Divide, is that what you were thinking? Or hopefully you already did it? Because you're not waiting for me and then just copying my answers. That's not learning. That's becoming an expert copier. And there's no job in the world for an expert copier. So what is it when you divide?
I got 16.44.
Agreed? I mean, I like that. That's good for me. So, the instructor needs to let 16.4 feet of rope out or off. I don't know what the right word is. Rope out.
Yeah.
Let the rope out.
Miss Grant,
Yeah.
what does it say over sine 165 above the 16.4?
61 sine 4. The same as right there.
Okay.
Okay. Good. So I used today already. I've done just a normal sine, cosine, or tangent. I used tangent, right? And then I did this problem where I had to use law of sines or law of cosines. I did law of sines. Now we're going to talk about how to find area of a triangle, a non-right triangle. Okay? So I'm moving. Okay. There's a special formula. So I have this triangle, and yes, I'm extremely aware that it looks like a right triangle. Okay. The point is that if I have this triangle that has no like real exact pieces of info, if I am given an angle measure, I'm just making this up, 38, and I'm given two of the sides, like this one's 12 and this one's like 19. This, if you see it, it's like side angle side, right? Well, I can use this angle and these two sides to help me find out the area of the whole triangle. I would do, let's call this angle A. This will be lowercase b and this will be lowercase c. I would do 1/2 of one side B times the other side. Now notice that it's the two sides surrounding my angle. C, which is 12. And then I do the sine of A. Okay? If you want to see it, so this is me just giving you an example with numbers. If you want to see it with this triangle, I'm not going to be given the height. So the problem is that since I'm not given the height, I need to make a workaround and figure out what it would be. So here's the formula that you're used to. Here's me deriving the formula. But I don't know the height. So for this triangle, I'm going to use, instead of height, I can do sine of A angle equals opposite over hypotenuse. This is just for the height, right? H over C. But if I don't know the height, remember, I don't know the height. So I'm going to work around and I'm going to solve this problem for H. C times sine of angle A is H. So in my formula, 1/2 base times height, C side times sine of angle A. If I need to know an angle, I multiply the two sides that I do know and the angle that I do know. So this is, I derived it for you. I showed you how to do it mathematically. And this ABC just means whichever angle you want. The main idea is, let me say it again, I want to know the area of a whole triangle. If I don't know the height, I use, and it's not right, it's not a right angle. It's just this, or right triangle, it's just this random triangle. the angle and its two closest sides. And here's the math. And I would actually put sine of 38, wouldn't I? Let's do that one because it's there. So (19 times 12 times sine of 38). The area is 70.1 units squared. I don't know if it's feet or inches, whatever, units squared. Right? Now I'm going to do another one. It's on the next page. But here it is. All right. 1/2 side times side and then sine of the angle. G times F times the sine of the 116. Well, G is 3. F is 4. One half 3 times 4 times sine of 116 degrees.
Miss Grant,
Yeah.
where did you get the 3 and 4?
Oh, they told me the sides G and F are 3 and 4
Oh, okay.
because we read the problem, so we know what they're asking and all that. What'd you get? The area is, what? It's still you, all the people on Zoom. How about someone that hasn't volunteered? Just sit here all day and wait for someone on Zoom to answer?
Yep.
So fun.
What if you were like just a call?
5.4.
Just let me wait. 10.5, wait. Say it again?
5.4.
Yeah. And the unit of measure is centimeters squared because area is always something squared. Good. Okay. So we're going to stop there on notes. I know there's more on the page, but we're not going to do it. I want you to look, we're close on time anyhow. So I want you to look at the attached, it's 5.4. You're going to have to draw the shapes. You're going to have to draw the triangles. Some of them are drawn for you. Maybe you use sine or cosine or tangent. If it's a right triangle, you use sine or cosine or tangent. If it's not a right triangle, you maybe use law of sines, law of cosines. Or maybe if it asks you to find the area, you use our most recent formula here. So go ahead and start that. I'll stay in class, especially since